I would like to now show you an example where we have a liquid solute, and the question is, for a mixture of 22 mils of furfural and 160 grams of ethanol, calculate the following concentrations. We've been given the densities of both furfural and ethanol here as well. The first thing we need to do is find the percent of weight of furfural, and to do that we're going to need a mass of furfural. We've been given a volume and we need to use the density then to convert that into a mass. Now that can be done by taking the volume and multiplying it by the density. Here you can see that the milliliters will end up cancelling to give us grams, so that will end up showing us that we'll have 25 grams of furfural. So what we're going to do now is we're going to figure out the percent of furfural in the solution, and we're going to take the mass of furfural and divide it by the mass of furfural plus the mass of ethanol, which was given to us in the problem, and that comes out to 14% of furfural. The molarity of furfural will be found by taking the moles of solute over the liters of solution. Now this is important now because you've got to remember that in the previous example where we had a solid solute, it was only necessary to worry about the liters of solvent. We didn't have to worry about the liters of the solution because the solute did not appreciably add to the volume of the solution. However, now what we've got is a liquid solute, 22 mils of furfural, which is going to now factor in to the total volume of solution. So what we're going to have to do is find the volume of ethanol used here. We've been given 160 grams as the mass. We've also been given the density, and as before we can find the number of mils by multiplying by 1 over the density. So mass times 1 over density, or mass divided by density, and this would be 160 grams times 1 mil over 0.789 grams, where the density was 0.789 grams per mil. You can see the grams will end up cancelling and leave us with 203 mils as the volume of ethanol. The volume of furfural was given to us in the problem as 22 mils, so the total volume of solution will be 22 mils plus 203 mils, which is 225 mils. The molarity, however, is moles of solute over liters of solution, which necessitates us converting the milliliters into liters, which is 0.225 liters. The molarity of furfural then will be 0.25 moles divided by 0.225 liters to give 1.1 moles per liter, or 1.1 molar solution. So the big M is pronounced molar or moles per liter. The number of significant figures is decided here by the number of moles, which was 2 significant figures, so we have 2 significant figures here as well. The molality is going to be the moles of solute over the kilograms of solvent. This doesn't change regardless of whether or not we're using a solid or a liquid solute. In the case of a solid solute, it was still the kilograms of solvent. In the case of a liquid solute, it's still kilograms of solvent. So molality only takes into account the mass of solvent. The mass of solvent here was 160 grams of ethanol, which it gets converted into kilograms, 0.160 kilograms. The molality then will be 0.25 moles divided by 0.160 kilograms to give 1.6 molal or moles per kilogram. Either one of those is the correct way of saying that. So the little m here stands for moles per kilogram, or molal. Again, I want to point out that the molality and the molarity have different values because the solvent has a density that is not 1 gram per mil. The mole fraction of the furfural will be obtained by taking the moles of furfural and dividing by the moles of furfural plus the moles of ethanol. In order to do that, we need the moles of ethanol, and we can get that by taking 160 grams times 1 mole over the molecular weight of ethanol. Remember that in both instances we have been given the molecular formulas, and that's what's enabling us to calculate these molecular weights for both substances. So then we can find out the moles, and then we can calculate the mole fractions. 0.25 moles for the furfural over 0.25 moles plus 3.47, so that's the furfural, and the ethanol. And that comes out to a value of 0.067, 2 significant figures, 2 significant figures. The mole fraction of ethanol, 3.47 moles over 0.25 plus 3.47, is going to come out to 0.933. And as you can see from this, the units on this, there are no units on mole fraction. It's dimensionless, and that's because the moles end up cancelling. And again, we can get the mole fraction of ethanol by subtracting the mole fraction of furfural from 1, and that's not just another way of getting it, and that will also take into account the correct significant figures as well, because this will be 3 decimal places and this will come out to 3 decimal places.